All right, now when we go to set our laser up, starting out with the tripod here, basically you'll notice there are two clips on the legs of our tripod here. We just let out the upper clip, let that leg all the way down on all three of these legs here, and that's pretty much going to get us perfect height to shoot 99% of the countertops we ever come across. The only time I adjust the height of this is when we're dealing with vertical applications such as full height backsplash, shower walls, fireplaces, tub decks. Those are the kind of things that the only time I will adjust the height of my laser here. So that's perfect height to shoot 99% of the countertops. Now when it comes to setting our laser up here, very important, this little silver T-knob right here up at the top of our tripod. We want to make sure, super important, to tighten this bolt down once we set that laser head up on top of our tripod here. So we basically take our laser head, drop it on there, and then we're going to tighten up that silver T-bolt super tight to make sure that that laser, the base of that laser, is locked into place there. Now, as far as the tablet goes, the bracket here has just got a little peg on a hole, little peg right there on the bracket. That peg goes into a little slot in a hole cut on the side of the top of the tripod. Now, as far as the cable goes, you'll notice the cable comes out of the front left corner of the machine here when it's aimed away from us. So we take the cable from the front left corner, run it underneath the left of the tablet, and plug it into the right side of our tablet here. Now, on these Surface Pro tablets, there's only 3 buttons, a power, a volume up, and a volume down. So we tap the power button here. That's going to fire up our desktop. Now, as far as the laser head goes, on the front of the laser here, there's a silver power button. We tap on that power button. We get a little green LED on here with a laser dot coming out of our laser. So once we got this turned on, we see our little laser dot there. We got the USB plugged into the side here. The software that we will be using is Laser Templater on our desktop here. We're going to tap Laser Templater there. Going to open up our software. First message we're going to see right here, it says, as part of the startup procedure, the 2D, 3D must be locked in the horizontal position. Using the 2D lock, if it is not already, please fully engage the 2D lock now. It can be unlocked after the program starts. Failure to do so will result in inaccurate measurements. So when we see this message up on the screen here, there's basically 3 things we're looking for. Our USB is plugged in at the side here. Our laser is turned on, and the 2D lock is in the locked position. So what this message here is referring to is these 2 red dots up at the top of the machine and this little spring-loaded knob here. We can pull this knob out and twist it like a screw, and that unlocks the 2D lock here. So when we see this message on the screen, we better make sure those dots are lined up, and we spin that knob around so it pops into place, locking the 2D lock in place. All right? So I got my 2D lock locked, laser turned on, and the USB plugged in. We can hit OK on the screen. Laser's automatically going to connect up. You will get a little tips and tricks window here. You can just hit close on that. And as long as you did everything right, the first screen you should be looking at here is the laser asking you to set a plane. Okay? So we're all connected up here. The 2 biggest takeaways from the setup here is making sure that that T-knob is tight. On the laser here, the T-knob is tight, and we have the 2D lock in the locked position. 2 most important things when it comes to connecting up the laser to the software here. Once we see the set plane window, we basically figure out where are we going to place this. Once we see the set plane, we can pick it up and move it anywhere we want on the job. Generally speaking, we're going to want to set up in front of sync center. The reason why we want to set up in front of sync center is because when we aim this laser straight out in front of us, you'll notice that there is a nice little dot out there on the wall. Okay? And we always want to make sure we have a nice little dot whenever we go to shoot sync center, cooktop centers, outlets for full height backsplash. Anytime we're shooting a very accurate single data point to drop a cutout onto, we want to make sure we have a nice little dot there. Now, that's why we set up in front of sync center. When it comes to just shooting cabinet edges, face frame measurements to generate a finished edge, we can stretch the laser up to 1 inch. So we give you a little card in the box there to show you what laser stretch looks like. And so we never, ever want to stretch it when we go to shoot a sync center, because I can't tell you if it's going to measure the beginning, the middle, or the end of that stretched out laser. So we always want to make sure we got a nice little dot when we go to shoot location measurements, sync center, cooktop center, these kind of single data points. We always want a dot. When it comes to just shooting face frames, panels, scribing drywall, we can stretch it up to 1 inch and still be accurate. Okay? Now, that doesn't mean I have to set up right in front of my sync center here. I could also move my laser back a little to where now I'm in the middle of my stove opening here. So now my laser's in the middle of the stove. I can shoot right onto the left, right onto the right. I still have a good angle back to sync center. Now the only thing I can't see is my left panel over here returning to the wall. I'll need to use some kind of targets to capture that. So you can move your laser around a little bit off of sync center based off of other things you're trying to template in that shape of that kitchen to where we don't need to use targets on them. Okay, so since we can't see that left end over there, we're going to use some kind of target. I'm going to show you my favorite target here. It's what we call a T target. Okay, you get 6 of these in total. Three of them with tabs bent down on my left, 3 of them with tabs bent down on my right. The reason why we give you them bent left and right is if we're shooting panels or styles. Okay, style is the face frame sticks out past the cabinet. I'll show you that in a second. So what we're going to do here is we can't physically put our laser on the outside of this panel from this location here. So when it comes to styles on the cabinets here, we have this 1/4 inch face frame that sticks out past the panel here. And so what we're going to do is if I try to use this one bent down on my left, no, that's bent down on my right. If I try to use this one bent down on my left and set it up on the front, it'll fall right off. Doesn't matter how many times you flip it, it will not set on the front of that cabinet. So we grab the one that's bent down on the right here, and when we set that on the style, on the front edge, it will stay sitting there. That's to get the style from in front of my stove over there. Now, if I want the panel, if I try to use this target on the panel, it will not work. It will not stay up there. So we grab the one bent down on the left. It'll sit up on the panel, up on the front edge. Now from that location, I can shoot on this tab here to get where the panel is at. Okay? Now, this is what I consider a good angle target. From where I'm located at in front of the stove here, we can turn our laser around and we can aim at that target. I have a good angle to this target. which is why I have a nice little dot on my T-target there. Okay, so perfect setup. This is what I consider my good angle target. What's a bad angle? A bad angle is when you set your laser up and you'll end up directly in line with a panel, with an edge. So you see here, our laser is lined up directly in line with this panel. So I can only get my laser dot on top, or I can get it on the back wall to the left or the back wall to the right. I cannot physically get my laser on either side of this panel here. So what I like to do in this situation is use pin blocks. So we're just going to take 2 of these blocks. We're going to pick a line on the block here, and I'm just going to line that line up with the cabinet edge I'm trying to capture. So we stand it up here, aiming the sticker back at our laser, and then I just line that red line up right with that edge there. Take one in the back, line the line up with that edge there, and now we just aim our laser dot right onto the laser line. And so as you see, I just have the line lined up with the edge, and we put our laser right on that line to shoot one point in the front. Laser line lined up with the edge in the back. We shoot right on that laser line to generate the second point. 2 points for each edge. So this is what I consider my bad angle target. We just line a line up, shoot the line. T-target's what I consider my good angle target. And we can aim over right at that guy because we have a good angle to it, and we get a nice little dot there. Okay, so these 2 targets right here are all I need to use to shoot the whole job when it comes to new construction. I can shoot every countertop without an existing top in place, just using these 2 targets right here. T-target when I have a good angle, pin block with the line when I have a bad angle. We can set everything with just that. Okay. Now, when we go to set a plane now, so now the laser's asking us to set a plane. It's looking for a left, a right, and a back point to establish this plane here. So we're going to use pin blocks to set this plane. It's the first method I'm going to show you here. So here we got these blocks. We're going to take 3 of them because the laser is asking us for 3 points. So it's going to be, we see this bold black line, an arrow pointing up at it, and below that arrow it says set plane. So we take 3 of these blocks, we stand them up on end with those arrows pointing straight up into the sky, and we're going to aim onto the black line when we shoot with the laser to set this plane. So we're going to go as far left as we can go on the front edge, as far right as we can go on the front edge here, and then somewhere in the back middle. We could go up against the back wall here, we could go up against the back wall here, or somewhere on Lazy Susan. Okay, so now I have my left target here, and we're basically just aiming our laser over onto that black line and shooting a point on that black line when we're going to set plane here. So we just aim right onto that black line there. So we have our left block, our right block, and our back block to set the plane here. Okay, so that's method number 1 that is provided with the laser system for you. The second method that we're going to talk about here is using a self-leveling laser. Okay, we can turn this guy on, set it on the face frame over here, and now you see it's projecting a perfectly level line in our whole kitchen here. So we can literally take the 2D, 3D, and we can aim our laser dot right onto that laser line and shoot our left point, come over here to the right shoot the right point, and then come back here and shoot a back point in the back there. Okay? So this is the two methods we can use to establish the plane, either the blocks or the laser. When we use the blocks, we're creating a plane in space that matches what the carpenter gave us. So whatever the surface, the cabinets are, however level or unlevel they may be in space, our blocks are telling us exactly how these cabinets are mounted. Now, when we use the self-leveling laser, we're creating a plane that is perfectly level in space. Okay? So the two methods we're using here is, one, we're either matching the surface the carpenters gave us and what the cabinets are producing, or we're perfectly level in space. Okay? These are the two methods we want you to use, the only two methods we want you to use when it comes to setting a plane for countertops here. Now, what this plane is doing, once we shoot these 3 points, this plane is floating in space here above our countertop. And when we shoot points down on the face frame here, it moves that point up through space to the plane. And then if we shoot points above the plane on the back wall, it moves those points down through space at a perfect 90-degree angle to the plane. So we are flattening this out as we create it. We're flattening everything out to this plane. So, because when we send this to the saw, when we send this to a plotter, our saw just wants to see a shape of the counter. It does not want to know a depth. We tell the saw how thick the stone is, and that's how it knows how to cut that out. We are just providing it with a shape of what this kitchen is, and by setting this plane and flattening everything out to it, that's how we can take these files straight out of Laser Templater, straight into a saw, and cut from them, because they're already flattened out. All right? Now, as a general rule of thumb, I never want you to shoot points more than 6 inches below or 6 inches above the plane that we establish here, okay? Because we know that these cabinets are out of plumb. We know the wall is not flat or plumb at all. So if you were scribing your back wall here and for some crazy reason you decided to shoot a point up here on the wall for your back scribe, if this wall is bumped out a 1/4 inch different from down here where our countertop's going, well, when we shoot our point up here, it's going to move that point through space down to the plane. And since that wall's out a 1/4 inch, when you pull your tape measure out and check this, you're going to be a 1/4 inch off because the wall's out a 1/4 inch where you shot your points at. Okay, so we always want to be within 6 inches of that plane to increase our accuracy and to take the factor of these things being out of level and out of plumb, to take that out of the equation and to make sure we get good, accurate measurements. The closer you shoot your points to where the plane is and where the stone is actually going to exist, the better. Okay? So, now, super important to make sure we shoot these points in the right order. Make sure you pay attention to the screen here to where it says point 1 left, point 2 right, point 3 back. The problem that people have is they ignore the screen and they just shoot a left, then they shoot a back, and then they shoot a right. If you do not follow the order that is on the screen here, you will mirror your drawing and you will flip it. So when you start measuring, you'll see on the screen, you measure 2 points on that panel, 2 points across the front, and you'll see that it's drawing it on your screen like it's off to your right. And that's simply because you set these plane points in the wrong order and you have mirrored this. Now, if you don't catch that and you cut this kitchen out and you go to install that kitchen, the shiny side of your stone is going to be down. We're going to take that whole kitchen and we're going to throw it in the garbage and we're going to start over again. So please, I cannot stress enough, make sure you follow the order of set plane here to make sure that you shoot point 1 left. Hey, I get a little green checkbox. Now we say point 2 right. Hey, I aim over here to the right, tap the screen, boom, I get a little green checkbox on the right. Now we aim back and we take that shot, boom, we get a little green checkbox next to back, hit OK. Now we know our plane is set in the proper order. Okay, so can't stress enough, make sure you shoot those plane points in the proper order there. Okay. Now, once we set the plane here, we're going to cover 2 more topics. Number 1, green sticky dots here. So these green sticky dots, we're using laser light to measure distance here. Okay, so whenever we're shooting onto surfaces such as granite, marble, quartz, corian, glass tile backsplashes, translucent tiles, full height backsplashes, if we're going to shoot directly onto those surfaces, our laser light can be absorbed by that surface. If you aim your laser at a clear piece of a clear mineral in a granite countertop, our laser is going to penetrate into that surface and give us a bad dimension. So these stickers are there to stop our laser at the face of that surface to give us a dead accurate measurement right to the face of that, to stop the laser light from being absorbed into that. So that's anytime we're going to shoot onto stones or tile or corian, we got to watch out for that absorption. The other thing these sticky dots are for is whenever we're going to shoot dark cabinets. So any black cabinets, dark espresso stains, dark mahogany stains, the laser, when you aim the laser and go to take that shot, you'll get a little message pop up that says problem taking measurement. That means the laser light cannot see itself. It cannot get a distance based off of that dot is being absorbed by the surface we're aimed at. So we need to put these little green sticky dots on dark black cabinets, dark espresso stains, dark mahogany stains, and it'll stop that laser from being absorbed into that surface and give us an accurate measurement. Okay, so these green dots are for any stone and any dark surfaces we're trying to measure on. I'll color black. Opposite end of that color spectrum is white. White is going to reflect the most amount of light here. So the situation you end up in with this white cabinets here, like behind me, is you will set your laser up, and when you go to aim at the back corner of this panel right here, you will get reflection. So what's happening here is I'm actually aimed at the panel, but you can see my laser is reflecting onto the back wall, and we have 2 dots right there. So what we're going to do to fix this is in your laser kit, you will have 4 of these black fuzzy shields. This is a shield. It's not a target. So we don't ever actually aim at this and shoot on it. We use it to absorb the reflection that is coming off that panel. So what we do with this, we're going to trick the laser. We stand this up against the back wall. So now the reflection is bouncing off my panel, landing on the black shield. The laser cannot see the reflected dot. It can only see the dot we have aimed at that panel. And this will give us a dead accurate measurement every day, all day. Okay, so we got to watch out for reflection here and use the black shields to fix this. Anytime it's an inside corner, typically where panels meet drywall, or inside corners on L-shaped, we can get reflection here as well. So we want to watch out for it on inside corners and panels, pantry panels, fridge panels, that kind of thing. We got to look out for this reflection. All right.